Fractions and ratios are really important in physical science, so you need to understand what they are and how to work with them. Let's start with some terms. A fraction is a part of a whole. We write a fraction as one number over another number. The top number is called the numerator and the bottom number the denominator. We'll look at what these words mean just now. A ratio is basically also a fraction. It's a relationship between two or more amounts. It can be written in the form that we used to with a fraction, or it can be written as something is to something else. Inverse means kind of upside down. So the inverse of x over y is y over x. Notice how we flipped the fraction around to make the inverse. Fractions can be written in the form a over b. A is the numerator, b is the denominator. The denominator tells us how many pieces the whole is divided into, and the numerator tells us how many of those pieces we're speaking about now. For example, 4 over 12 can be thought of as we have a pie, we cut it into 12 pieces, so the whole is divided into 12 pieces, 12 being the denominator, and we can eat 4 of those 12 pieces. So we get 4 out of the whole if the whole is divided into 12. Now this fraction can be simplified into the form 1 over 3. Because can you see that dividing the pie into 12 pieces and us getting 4 pieces gives us the same amount of pie as if we'd rather divided the pie into 3 pieces and we'd been allowed to take 1 of those pieces. We can also see this by dividing both top and bottom of the fraction by 4. 4 divided by 4 equals 1. 12 divided by 4 equals 3. So 4 over 12 is the same fraction as 1 over 3. So we've seen that the coloured part of this picture is a third, which can also be written as 4/12. Now imagine the same circle being divided into 6 pieces. How many of the 6 pieces are coloured? In other words, give the fraction 1/3 in the format something over 6. Pause until you've done this. The answer is 2 over 6. You see here I'm dividing this pie into 6 pieces and we are getting 2 of those pieces. In other words, 2 of the pieces are coloured. Now look at the part of the fraction that is not coloured. Write that as a fraction in at least 3 different ways using 3 different denominators. Pause until you've done this yourself. The pie is divided into 12 pieces, and 8 of these pieces is not shaded. That means that the non-shaded part is 8/12 of the whole. We can also write this as 2/3. If we imagine this pie, the circle being cut into 3 pieces, the part that's not shaded is 2 pieces out of those 3, 2/3. You can see that 8/12 and 2/3 is the same thing. Divide both top and bottom by 4. 8 divided by 4 equals 2. 12 divided by 4 equals 3. 8/12 equals 2/3. We can also write this fraction as 4 over 6. Imagine this being divided into 6 pieces. 4 of those pieces are not shaded. We can also see that 2 over 3 is the same as 4 over 6 if we multiply both top and bottom by 2. 2 times 2 is 4, 3 times 2 is 6. Or we could divide both top and bottom of the 8 over 12 fraction by 2. 8 divided by 2 equals 4, 12 divided by 2 equals 6. So these 3 fractions all mean the same thing. 8 over 12 equals 2 over 3 equals 4 over 6. How do we multiply fractions? Let's use x over y multiplied by y as an example. X over y multiplied by y equals x over y multiplied by y over 1. Can you see that we are saying y divide by y over here? Anything divided by itself is equal to 1. So we can cancel out the y from the top of this fraction and the bottom of that fraction, and so simplify our answer to simply equal x. When we divide by a fraction, we use a trick called tip and times. 3 divided by 9 over 2 is the same as 3 over 1 divided by 9 over 2. We tip the bottom fraction and times it by the top one. So that equals 3 over 1 times 2 over 9. We can then do some simplification because you can see that this is saying 3 divided by 9. 3 divided by 9 is equal to 1 over 3. We divide both top and bottom by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So we've simplified this to 1 over 1 times 2 over 3, which is equal to 2 over 3, also called 2/3. Here's another example. Try this yourself before I show you the answer. W over x divided by y over z is equal to w over x multiplied by z over y. Notice we've tipped and timesed by the bottom fraction. That is equal to wz over xy. Exponents. We can also write fractions in the format of exponents. For example, 1 over x is equal to x to the power minus 1 to the power minus 1 means the inverse of. So the inverse of x means 1 over x. What about 1 over x squared? We can also write that as x to the power minus 2. The minus tells us that it's inverted, in other words, at the bottom of the fraction. And the 2 tells us it's squared. Ratios. Ratios can be written as something is to something else, or just plain in a fraction format. You can simplify a ratio by dividing through by the same number. So let's see that these 3 ratios are all actually the same ratio. 1 is to 2, 2 is to 4, 3 is to 6. Notice that in each case, the second value is double the first value. We can also see this by dividing through by the same number in each case. For example, 2 is to 4. We can divide both sides of the ratio by 2. 2 divided by 2 equals 1. 4 divided by 2 equals 2. So we can see that 2 is to 4 is the same ratio as 1 is to 2. For 3 is to 6, we can divide both sides by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 3 is to 6 is the same ratio as 1 is to 2. These ratios simply tell us that one value is double as much as the other value. Now you're very used to working with ratios when you mix juice, so let's use an example from mixing juice. Here are 4 different mixtures of juice. Let's think about these 4 mixtures and think about which one's going to be sweetest, and are any of them going to be equally sweet, which is going to be the most watery. First mixture has 1 cup of orange juice for every 3 cups of water. The second mixture has 2 cups of the concentrate, the orange juice, for 6 cups of water. Can you see that these 2 mixtures are going to be equally sweet? Because in both of them, we have 3 times as much water as we have orange juice. So the ratio of orange juice to water in both cases is 1 is to 3. We could write mixture 2 as having a ratio of 2 is to 6, but that is the same ratio as 1 is to 3. Which is why they're going to taste equally sweet. What about mixture 3 and mixture 4? In mixture 3, we have 3 cups of orange juice for 5 cups of water. Is this going to be sweeter or less sweet than mixtures 1 and 2? Then mixture 4, we have 4 cups of orange juice for 13 cups of water. How sweet is that going to be? Is it going to be very sweet or is it going to be very watery? You answer those questions while you pause the movie and then let's discuss it. Mixture 3's ratio of juice is to water is 3 is to 5. You could simplify that by dividing through by 3 on both sides. 3 divided by 3 is 1. 5 divided by 3 is 5 over 3, which is equal to 1 and 2/3. Now remember, mixture 1 and mixture 2 have the ratio 1:3, meaning for every 1 cup of juice, you have 3 cups of water. Now for mixture 3, for every 1 cup of juice, you have far less than 3 cups of water. You have only 1 and 2/3 cups of water. That means that juice 3 is going to be very sweet because it's got much more juice compared to water than mixture 1 and 2 have. So that's going to be the sweetest juice. Now let's look at mixture 4. For mixture 4, the ratio is 4 cups of juice is to 13 cups of water. We can simplify that by dividing both sides by 4. 4 divided by 4 is 1. 13 divided by 4 is 13 over 4, which can be simplified as 3¼ So the ratio for mixture 4 is 1:3¼ That is more water per juice than mixture 1 and 2, because for mixture 1 and 2, it was 1 cup of juice for 3 cups of water. So mixture 4 is more watery than any of the others. It's got more water per amount of juice. And so mixture 4 is going to be the least sweet, the most watery. To answer question C, we must list mixtures 1 to 4 from the least to the most sweet. The least sweet is mixture 4, the most sweet is mixture 3, and 1 and 2 are in the middle, equally sweet as one another. Check whether you've understood what we've done in this lesson by answering these questions. Pause the movie until you finish that, and then you can see the answers.